Hello everyone, welcome to our Egyptian online seminar group. First, you can use off, then if you have any questions, you can ask our speaker during his presentation or after his presentation. I have great pleasure of welcoming dear Professor James Ohlson. James Ohlson is one of the top accounting thought leader in the world. His currently position is at Stockholm School of Economics as an affiliated researcher. Now we will start our seminar with dear Professor James also.
All right. Thank you very much. I hope you can hear me good, everybody. Am I clear? And so I guess I should keep going for somewhat up to an hour, and then we leave it open at that point. Is that okay, Mohamed? Okay. So today's paper actually been around for a few years. I have presented it before, and the reason I wrote this paper, which has to do with the simple fact that over the years, I've written papers which are very critical against what we're doing. In other words, somewhere along the line, I came to recognize that papers with credible conclusions is actually quite low. In other words, there's a problem in terms of what we're doing when it comes to data analysis. And this is what I'm talking about. So basically what I'm going to have are two parts to my presentation today. So you sort of have to bear with me. The first part has to do with the fact that I want to try to give you a sense of how this is what we're doing, and here are the problems with what we're doing. And that raises the question, why are we doing what we're doing? And if you end up being somewhat negative, and this is sort of what happened to me because I talked about what we're doing is not that good, then the question is, what should we be doing? So that's sort of the second half of today's paper. I'm actually going to come up with actual prescriptions. This is how you should do your data analysis. But to understand that, sort of to rehearse this, to understand that, it has to do with the fact, what are we actually doing, and why are we doing what we're doing, and what are the consequences of what we're doing. So please keep that in mind here, that the real takeaway is going to be the second half. Then I'm going to come up with 4 prescriptions, which I follow myself, and this is what you can do, and then it's a different ballgame. However, the background is very important here. So I want to try to connect with you, especially those of you starting out in this business, how you experience this business. And the first thing that pops up here is the big issue that when you engage in research, and this has nothing to do with accounting, there's much written about this in the public press, and there are scandals and whatever have you. And it has to do with the question, are you willing to mislead your audience? It's a good question. You all know about publish and perish, and you know that the stakes are very high. So that's sort of what's lurking in the background is that many people say, yeah, I guess so. And I'm not going to tell you about what you should be doing, but the first order of business is that if you want to engage in research, do not fool yourself. If you want to mislead others, it's up to you. But never, ever get involved in this thing. Is that some people have difficulty being dishonest because to be credible, you have to fool yourself. And what I'm saying here is don't fool yourself. Avoid fooling yourself. And why does this happen? So when I get to the next point, which you're all familiar with, or have some kind of experience, is that when you engage in research, empirical research, it tends to be the case that you have engaged in wishes. You want to find certain things. And the reason is that often you come up with a fairly far-fetched hypothesis, a non-obvious hypothesis, and you want to show that this actually holds up. The reality is that when you do this here, and that's my third point here, is that when you engage in research, you often find things that you don't like to experience. This is not what I had in mind. And then you run into the problem here is that Do you want to talk about this? And then we run into a very peculiar thing is that it's just like the court system in the US, or at least the way it used to be. You cannot lie in courts, but you can, if you're a lawyer, but you can withhold information that you have, but you don't want to reveal. This, in my mind, is amazingly common. It's just amazingly common. And I have lots of indirect evidence. And if you want to talk more about that later on, if time permitting, I have some very funny stories about this here. So then I get back to the basic thing is don't fool yourself. Do not fool yourself. If you suppress information, you suppress information. So the spirit of what I'm doing today is to say, this is what you should be doing. But if you have a good question, you could be neutral. You just want to find out what you want to find out. You don't have any preferences. You just want to know. Think about, you don't have to publish. You want to know what is going on with data. So if you test the trading rule, to take the extreme example, you say, I wonder if this trading rule works. I don't care about publication. I just want to know, does it work? And that's sort of how it should go down to here. Now we get down to the fourth point here. And this one is very important, and it's going in today's talk. It's that I'm referring to GARP. GARP is generally accepted research procedures. Over time, listen to this carefully, they evolved in such a fashion that you drift into it because they are very helpful to help you to show what you want to show. The problem is you can do that. And I tell my doctoral students, go ahead, but today's talk, don't deceive yourself. So I'm going to talk about GARP. But that's sort of a peculiar thing. In other words, somewhere along the line, I'm going to talk about that later. You have things like fixed effects. Why do fixed effects come around? Because it makes it easier for you to find what you want to find. Go ahead. We will have to make a living, but don't fool yourself here. And so that's sort of the red stuff here at the first slide here is that I'm talking a little bit more about this here, but many papers misrepresent the evidence as experience. To take that for granted, it puts you in shape, because when you get down to 2i or whatever have you here, and you sort of look around and, oh, now I'm getting what I'm wanting. You're doing what everybody else is doing. Not everybody, but most people. So today's talk revolves around not how to get to publications. It revolves around what should I do to understand the data? And the data has its own story. So that's today. So can you see this here? Yeah, the standard regressions. Can you read that clearly? That's the heading. Okay, thank you. So let me say a few things about what you already know here. And this is sort of what people do. And this is not what we're going to be doing or what I'm recommending. You run regressions and you have a dependent variable. And then, of course, you have what I call MVI, main variable of interest. It could be two if interactive. Then you get used to controlling variables and you have fixed effects. So that's sort of a standard thing that people do. And then the whole idea is that the main variable of interest should be statistically significant per some hypothesis. So you look for the correct sign. The magnitude of the sign doesn't tend to be that important, but this is what people do. Now, so then this is how you experience the business, simplified, but then you have MVI, the number of stars. So you get involved in star gazing, plus the correct sign. And after that, you have that, then you got to use up your 30 pages or 30, 40 pages. Then you do sensitivity analysis, and then you have different definitions of DV and MVI and whatever have you. So you do all of these things. So that's sort of, roughly speaking, there are many things I can do to show that no matter how I look at the data, it works out. And then lately, the past 10 years or so, we get into economic significance. More about this later here. So that's sort of roughly, very crudely, what people do. However, you also are aware of that there's a problem, which we could refer, broadly speaking, to in the social sciences, that's referred to as the replication crisis. Have you all heard about that? I think most of you have heard about it. And it has to do with the fact that you say, well, if I try to do the same thing, it's going to be some difficulty. You can always replicate it in a mechanical sense, but suppose you just started from scratch and come up with your own definitions and whatever have you. It's sort of, you don't really know what to expect here. And this really comes up very much when it comes to economic significance. I have more to say about it, but people read papers, they listen to seminar presentations, and the way I learned about this, I started to recognize way back that people really didn't want to talk about their robustness test and the economic significance. You could check up on their body language. Oh yeah, all robustness tests work out then. Oh yeah, it's economic significant. And then we will move on. And we only, we only have 10 minutes left in our seminar, blah, blah, blah. So that's sort of a little bit how it is here. So the ground is somewhat soft here already. I have more to say about this here. Now, let me elaborate here, because I want to connect with you to give you a sense of, more of a sense of why I'm doing what I am doing here. So this is often what happens when you read papers or listen to papers. And so I refer to this as when you look at papers, you are consumers. So you look at things. And the first thing you realize that there's never any lack of stars. In fact, I think the typical paper has 400 stars or something like that. And it's stargazing. That's what I refer. And this is what it is. And then you also start to realize that robustness tests, they always work out. Have you reacted to that? Robustness tests always work out. And I have to throw in a story here, which is a true story. And this was about maybe 7, 8 years ago. So I was teaching a seminar for all of these young students, doctoral students. There were probably 15 in the room. And then I asked all the participants, did you ever see a robustness test which did not work out? And we all laughed and said, no, of course not. Then a young lady, she raised her hand, and everybody looked at her and says, what did you see? And then the answer was, oh, I've been working as a research assistant for a senior faculty member, and he told me do some robustness tests, and they never worked out. So the point being is that it's really, if you don't see what you like, forget about it. And so we have to come back to these things, but it's important that you have your own reactions regarding these things. Then you do your own research. So talking to people here, you often find it's tedious and lots of trial and errors. You run regressions, and you try this and you try that, and there are different schemes of clusterings. It's just endless. And as you do that, you often find that much of what you're seeing is not what you had in mind. But then according to GARP here, forget about it. If you see something you don't like, you can come up with excuses, often valid excuses, and you just forget about it. You do not have a special section in published papers that discuss, here are the things I found which I didn't like or contradicts. And generally accepted research principle now, they really help you when you do research, because there are good reasons for GARP. It helps you to get where you want. Not only a publication, it helps you get some order in terms of how to do the analysis. Moreover, it helps you to get what you want. So GARP really becomes very powerful. And GARP is evolving, generally accepted research principles, and that creates some chaos. So when ES came around, there was some confusion. How do you do ES? Well, you have to talk to your colleagues, because if you do ES by yourself, I don't see the economic significance. Well, go and see your colleagues. They will tell you how to do ES in such a way that you don't have to worry. It's going to be economic significant. Don't worry. Don't worry. Just ask around. They will tell you how to do it. And it's not that complicated, but there's some tricks there. So that's sort of a starting point here. Let me drill down and give you some more stuff here, because it sets the stage for what I'm going to talk about. What should we really be doing? So research seems much simpler when reading as opposed to doing. That is clear. Now, what I'm trying to do is, let's try to do things so it's simple. Don't go to chapter 13 in an advanced econometrics textbooks. Okay. And another thing is that, do people really care about what their conclusions are valid or not? Well, really what happens is that it's a very tricky matter, but in the real world, conclusions depend upon how you're looking at the data. And there is nothing wrong to find quote unquote contradictory conclusions depending upon how your data. So this is, in my mind, super, super important. So if you take a very simple problem like, say, risk and leverage, yes, there probably is a correlation between risk and leverage, but it depends probably how you do things. You can do time series, and you can do cross-sectional, you can have large firms, you can look at outliers, you can look at inliers, you have different measures of risk and whatever have you. To me, that's where the contribution will be. Okay, and then another thing, of course, is that most of you, when you run regression, what about controlling variables? Well, in the good old days, you can refer to prior literature, but that's laughable. That's not what people do at all. But try different things. Why not? And then lurking in the background, of course, is that you may not find what you want, so try different things. So then you start to learn that if you take something like ROA, return on assets, well, it's 10 different definitions. And as we move into AI, AI used to be called data dredging. In the future, we're going to have AI, which means that you actually have programs that sort out what you should be doing to get what you want. And obviously, in the background is what I said, that it select things. So you can try different ROA, you get different results. You should keep that. Maybe that's important to you. Okay. Okay. Then a few more things here is that the number of independent variable CVs have increased over time. Nowadays, it's 20. And you can try prior literature and so forth. You can give presentations and refer to the prior literature. Everybody will be quiet, but they don't take you seriously. Don't worry. There are many things you can say in the seminar, and people, if you listen at all, we don't ask you hard-ass questions, because this is the game we're playing here. And then you also find here that another thing that in the good old days, John Hand knows about this, we used to do Fama Macbeth, and it disappeared. Now the question is, why did it disappear? It makes it harder to get what you want. And I would say that may be true, but if you want to know how the data works, it's quite interesting. Does this work for every year? It's an interesting question. Suppose you might question the risk and leverage. Yeah, you find some correlation. Does it work for every year? Well, why don't you tell people? Avoid stargazing. That's the message. Okay, I'm soon done here before we get down to prescriptions. And how about this one? This one has become a favorite of mine here. But somewhere along, it occurs to people that as n increases, it makes it easier to get 3 stars. But then people say, well, if you have 50,000 observations and you have a t-statistics of, say, 3 or 4, my favorite saying, you have nothing to write home about, but you can always try to publish. But this is the brutal reality. And the funny thing is people never talk about it. And there are things you could easily do to check up what's going on, and more about that later. In other words, it comes down to, don't deceive yourself. If you have 4.5 and 50,000 observations, oh, you can declare a victory in your paper and then send it to JAE. Jim Ohlson says, it's okay, but don't deceive yourself. You have nothing. Nothing. And of course, it's very easy to check this. What happens if you delete the MBI? Does var squared change? No, the first 3 digits will be the same. Again, it's fine for a publication, but do it. So actually, there's sort of a funny history about that, because in the good old days, people used to check the change in R squared. But then people realize that you don't get what you want. If you have a first 3 digits the same, or something like that, you can't talk about that. But my favorite question, and in those days used to be when I attended seminars pre-COVID, I asked them, so what happens to var squared if you delete the MBI? And people said, I have to check. No, they already checked. They already know that. So what I'm saying is that nowadays people, don't worry, people are not going to ask what happens to var squared. But what I'm saying is that's the culture, but don't deceive yourself when it comes to these points. Now that raises the issue of the fixed effects. Why do I have fixed effects? Well, the most wonderful fixed effect is the time effect, because it raises the number of observations. Now we get down to something very, very, very basic. More n creates opportunity, the n number of observations, it creates opportunities, but don't deceive. Don't use it in such a fashion that you're just thinking about the audience. Think about it from your own point of view. I want to learn about the data. So you can find endless econometrics text about this fact. And then you get into 50 years ago, people wrote, you cannot look at t-statistics without worrying about them. You can't. And there are many funny stories about that. It's really due to Fisher. And the story is that Fisher, he was looking for work when he had to go where Neyman and Pearson were teaching in London. And the way the story runs is that Fisher got his job opportunity, but he was told, you cannot teach your own stuff. Because it's very criticized. In other words, it's sort of silly. More about that later. But these are sort of very simple points. And what I'm trying to tell you is very straightforward. Do what you want. Try to publish. It's up to you. But don't deceive yourself about these things. So when it comes to the fixed effects there, don't deceive yourself. Okay. It's all there so you can get what you want. All right, and actually it has some fixed effects has bonus effects. There's no such thing as the wrong sign on controlling variables. That's very nice. That's a bonus point. In the good old days, you have to check that. All right, now we are getting down to, do you see clearly here? Let's go on, what's 4 points? The top there. So now what I'm going to do is to switch gear here. And what I want to talk about are the things, this is what I do. And this is my recommendation. It's not complete. If you want to learn about what the data has to tell you about things. So it's sort of seeking, what does the data say? And the subtitle here really should be, forget about econometrics. Just forget about it. And what you should ask yourself, I have an important problem here, and I'm running my own business. I want to know how this works. Then what you would be doing, you would not run regressions. And it's well to note that when you go to the real world, people don't run regressions, and they don't look at stars the way you think from what we do. And in this regard, are you familiar with Piketty's famous book? The French economist that wrote about the income and capital distribution and that stuff was published about 5 years, New York bestseller. And it's a thick book. It's an empirical book. It deals with GNP and growth in GNP and income and wealth distribution, Piketty. And the question is, do you think he's talking about stars and t-statistics? No, he's not. The topic is too serious. So there's sort of intrinsic aspects to data, and that's what you're looking for. So the first thing is, if you actually have something like risk and leverage, why don't you do very simple things? In other words, in papers, we talk about descriptive statistics, and we have all of these correlations. What I am telling you is the totally obvious thing. If you have a DV and MVI, check up how they correlate and do it extensively so you know exactly how they correlate. In some sense, keep in mind here that this notion of CVs, controlling variables, it's a little bit background noise. And it's not irrelevant, but it's not the big thing. So the first thing you do is DV and MVR. So if you want to look at corporate performance and pay, well, get the numbers that you're going to work with and check up what simple bivariate analysis is all about. Then you run into something very, very, very important. Don't do simple analysis without having articulated your expectations about what you're supposed to find. Think that through. And then there are two possibilities. You don't find what you want to find, or then you have two possibilities. Be prepared that you're thinking about the DV and MVI are incomplete or incorrect, or you have manipulated the data wrong. This should take you a fair amount of time. But there are an endless number of problems which fit this in all of the social sciences. And then I have another advice here, that keep it as simple as possible. Start out with a 2x2 and check up. So for example, you may say, oh, companies with high cash flows are likely to show improved earnings in the future. Is that true? Well, why don't we check up? Cash flows may be positive or negative. Earnings may improve or may not improve. Why don't we do a 2x2 table? What do you expect to find? Articulate. If you don't find it, then you have to ask yourself, how did I compute cash flows? And then you sort of would think through, well, if I have a proper free cash flows and so forth, half of them should probably be negative and half would be positive. So you run into how do I define earnings? But keep in mind the simplicity here. The question is, do cash flows anticipate changes in earnings? It's a simple question. Check into it. This here would take you a lot here. And if you do correlations, I'd never do regular correlations. What do we call the regular R-squares? I only do ranks, but there are many other ways of doing it. And the one thing you can do and learn about is the Kendall tau. It's a very nice correlation metric. You never see it reported, but it's extremely robust and very intuitive and has many merits here. Then in addition here, I mean, it's really idiotic because it's so simple. You have some problems that are driven by outliers. That may be the hypothesis. So in sports, for example, if you take performance and pay, it's an outlier problem. So you have to check up, do I have an outlier problem? So for example, it may be, or it could be an inlier problem. So you have to sort that out in your own mind. We have this idiotic thing of running regressions, and you're not supposed to make a distinction. Everything is supposed to be normal, which is idiotic and bizarre. And of course, everybody knows not, but you get your t-statistics, and then you can play around and do whatever you want. But you notice here that what I'm telling you, and many people do this and be prepared. This is how the world works on a very basic level. If you do, listen to this, if you do this properly, you will never forget that you learned something about the real world. Even if you don't remember, you will remember. Why? Because you learned something. So you read about all of these questions about risk and leverage and whatever have you. Now you do an extensive bivariate analysis, many dimensions, and then you find out that this is sort of how the data works. This is how the data works. And then you ask, does it work the same for all years? Check it up. Check it up. Do you get the same result over the last 20 years? Maybe it's only 19 out of 20. It informs you. Maybe it's 18 out of 20. Maybe it's 50-50. Okay. So now you're almost done to some extent. No, you're not, because there's more to it. And oops. So this is the continuation here. So now you also comes down to maybe you want to have one or two. You may partition the data. So what I do is always I check up. I have large firms and I have small firms. So check up. Does that make a difference? So I do exactly what I did in I, but I'm now partitioned with that. I like that. And the same thing is that nowadays I don't worry too much about risk, but I check up. If you have above average beta as opposed to below average beta, you get the same results. So you have size and betas, and don't do anything fancy. And then you have to deal with if you want to do fixed effects in your reporting, do that. So you could easily then control for fixed effects. So you can do some simple, what you had in I here, but don't learn how it works. So you can ask the question, if I have fixed effects for size or different industries, does it change things? Does it change things? Most people, when they have these fixed effects, we say, why? And they don't talk about stars, they don't talk about science, and so why? Because they don't care. But you have to care. I only do 2I, and sometimes I do 3I, but we get to it. Okay. But notice here, everything I'm saying is really in the spirit of Einstein. Einstein said, do it as simple as possible, but no more. So there are limits to how simple you can make it, but keep everything else constant. Simplicity is a wonderful virtue. And you're going to have common sense. And you will learn about how the world works. Trust me. And in general, you will get disappointed in the sense that it's never going to be clean cut. Get used to it. That's where the insights are. So you should really I should put it in. You will get disappointed, quote unquote, but you're really learning about the world. And this is robust data analysis, non-parametric stuff. So if you revisited the data 5 years down the line, you have confidence. I would see the same thing probably. Now you're making serious progress. Am I clear? That's how you build confidence. And that's sort of a little bit here that you can check up on the FE and regressions. I get more to I don't really like this point here. And what you can do is, at the minimum, before you go to CV, you can do dependent variable, fixed effects, and MVI. And then you can do dependent variable on fixed effect without MVI. So that sort of just teaches you very basic things that you should learn about. If you plan to deal with fixed effects, do yourself a favor. What is the impact of these goddamn fixed effects? Do yourself a favor. They never, ever tell you in any papers what the fixed effects are, how they influence things. What they do is that you check these tables, fixed effects, and then you have why. They don't experiment with it. Why do you think that's the case? They used to. Because then you start to find that you don't get things you cannot publish. Because the name of the game is, if I have what I, quote, want, rather than what I learned, I stick to it. So do I come back to this here? Old and young alike, engaged in research, you don't care what you find, except that it has to be robust and credible. And that means that if I repeat this exercise on fresh data 5 years along, I'm going to find the same thing. And the insight is, that is the insight. You have credible results. And that's not the same thing as saying, oh, it's unambiguous. So it's very simple. And the virtue, of course, is that You don't have, I'm not going to, you don't have to read chapter 13 in advanced econometrics. You don't have to worry if you have a consistent estimator. What you do is to check for fundamental robustness. So that's the first thing, and the most important thing, and I hope you remember this. And I think I'm doing something very useful here. If you follow what I'm doing and you pick up on what I'm doing, you are not going to regret. Okay. Now here we have another thing here. And this is pathetic, but I have to tell you this. Have you noticed that when people talk about regression, we estimate coefficients, we tell you how many stars, but we never discuss the estimated magnitude of the coefficients. People do not care, there are exceptions, about the estimated magnitude of the beta coefficients, even the MBI. They only care about stars. And what I'm saying, that's fine. And what it really comes down to here, that unless you care about the coefficients magnitude, and sometimes that can be true, especially when you deal with equity valuation. But in general, that's not true. They put in whatever they put in, and they start to engage in stargazing. What I'm suggesting to you is very simple and very old-fashioned, that if you don't care about magnitudes, run standardized regressions. Do you hear me? The standardized regression means that the variables in question have mean 0 and, did I say that right? Yes, I think so. That's unimportant, but they have 1 unit standard deviation. That means that you start to look at the coefficients. And then now, with experience, you find out, oh, if it's 0.05, you see the estimated coefficients, if you have standardized regression, is very much like correlation coefficients. I says, oh, it's 0.05. I have nothing. Okay. If you have nothing, you have nothing. So that's a very important point. You're not losing any, the t-statistics will be the same. So what I'm saying here is that do not use standardized regressions when you have reasons not to. If you don't have any reasons not to run standardized regressions, run standardized regressions because they will tell you things. Am I clear? Run standardized regression unless you have some good reason for not doing so. So that's the point. Okay. So that's what it really comes down to is that, I'm going to, in some sense, what we're looking for are really what correlates with what, broadly speaking. And then we have conditional correlations. So once you move into this here, the correlations are more important than the stars. Am I clear? So I don't care how many stars I have. If I find that the estimated coefficient in a standardized regression is 0.05 or something like that, I really don't have anything. And you can take this one step further and look at like the good old days, really old days. Maybe John Henn has heard about this. We actually had, what do you call this? When you have sequential correlations, you bring in one variable after another to check up what's important. If you have a dependent variable and you have 20 controlling variables, you may ask, which of these 20 variables really are important? It's usually just 3 or 4 or 5. Well, what are the 4 or 5? Stepwise regressions, we call it. Okay, I never seen a paper with stepwise regressions published, but you can do it. You will learn how the data works. And then you can run stepwise regressions for each and every year, and you can see, do I get roughly the same thing? Yeah, if you do, you found this is how you explain the dependent variable. So it's very nice. You don't have to have a PhD here. Okay. So there's much like this you can do, and I have a few more things to say here. So read this and check out very carefully. This is what I have here. In here, 0.03. Okay. So it's sort of a little bit like you don't have to go through deleting a variable and check up what happens. You just run a standardized regression or stepwise regression. It will tell you things, especially if you do it over subsets of data. Do things change? And it simplifies much here. All right. So now we're going to go down to point number 3. I only have 4 points. And so far I had no questions. Okay, but let me repeat this. Unless you have a good excuse for not using standardized regressions, use standardized regressions. Okay. Nobody's going to follow my advice. But you can do it in secret. You don't have to tell anyone. Because you really learn about how the world works. All right. Number 3. And this is no, I have another one here. Okay. So here is actually a continuation. Okay. So basically here now, I'm trying to pull things together. You remember how this large N and 3 stars makes you uncomfortable? Well, there is indeed a connection here. So basically, what people like myself do here is when I calculate, when I get the t-statistic and I read the paper, I divide by the square root of n. Then I pretty much get the standardized regression coefficient. And so you learn after a while here, this is too low here. So you can actually start to experiment. So I have here, consider t equal to 3, n is equal to 10,000, or t equal to 6, and then you sort of get the hang of that. You get an answer for forgetting about what the reviewers think, because GARP is very generous. GARP is generous if you have stars and you claim robustness tests work out. You're welcome to the gang. You're going to get the publications and you may even get some citations, but don't fool yourself. So we get down to the first slide. Don't fool yourself ever. And if you have something like a T of 3 and you have N 10,000, no, sir, miss. You can't write home about this. You can tell your friends. And it may be good enough for publications. But you don't have anything. It doesn't mean that you haven't learned anything. But what you've learned is that this DVI really doesn't help at all on a basic level, substantive level, to explain the dependent variable. That's what you learn. That's an insight. Maybe it's different if you control for size or whatever have you. That's fine. Go ahead. And sometimes it actually turns out that makes a difference. So it's quite exciting, actually. So when the problem, for example, when you take risk and leverage, you don't get much. But why don't you focus on outliers? Oh, now the ballgame changes. All right. So here's what I want you to remember. And if you teach a doctor program, this is what you should treat. Point 3i here. If you run a simple standardized regression, y on x, the estimated slope coefficient is equal to the correlation. You hear me? The estimated correlation is the correlation coefficient. That's the estimated slope coefficient. And so it's equal to the core. And if you want the t-statistics, just multiply by the square root of n. What is more important? The t-statistics or the estimated coefficient? What is more important? The t-statistic or the estimated coefficient? Well, so if you don't give me the estimated coefficient, and I want that sort of the thing is which is now correlation, is the standardized regression. I want to divide by square root of n. That's what you should teach in an introductory course. Do not forever forget the point 3i here. And to be absolutely clear, crystal clear, I'm not saying anything which is slightly new. This has been around for decades. It just turns out that in the social sciences, we like to make points. The points we make are eccentric hypotheses which hold up in spite, so to speak, of all robustness tests and whatever have you. That's our business. And then the virtue of it is that when you read the abstract, you say, this is not plausible. Guess what? Don't waste your time reading the paper. It's probably not important. And if you start to go through the diagnostics of what we're doing, no, it doesn't hold up. And all power to the authors. You know, they get the publications and they can put it on their CV and we get tenure and promoted and whatever have you. Okay, but this is what you know, and this is what your students should know here, is that the two I here is that classical statistics and large N do not mix. This is the virtue with Farmer-Macbeth. I split the sample into subsamples. So one way of doing data analysis, give me the subsamples in its reasonably randomized fashion. And if it works for every subsample, so if I have 10 subsamples and it works for every subsamples, I'm done. It's 10 out of 10. I don't need any statistics. If you want to correlate unexpected earnings and returns, and you find it is 10 years out of 10 or 20 years out of 10 or whatever have you, you have an insight. You have an insight. So that's what I'm saying. And if you, so this is sort of drifting into 0.3i, it drifts into statistics, but it warns you, don't confuse yourself. And even worse is when we start to argue about, like the textbooks, you know, about p-lim and stuff like that. It is in general totally irrelevant. And I can add on even 2i here, but t-statistics are intrinsically, in generally, overstated. You don't need a piece. Just run some simulation and check out. But t-statistics are not t-statistics. But doesn't mean that you cannot do data analysis. So ask yourself what it does. And if it doesn't work, it doesn't work. It's okay. But you will find out it works sometimes and sometimes not here. So that's sort of my comment here about Farmer-Macbeth here. It's just an experiment. Sometimes we refer to the literature that Farmer-Macbeth can overstate t-statistics. I know, but that's not the problem. In other words, people come up, there's demands for rejecting Farmer-Macbeth analysis in GARP. So someone came up, well, yeah, of course, with t-statistics, you don't have to do t-statistics in Farmer-Macbeth. Just check the signs. Do you get the same sign in every year? Okay. If you do, you do. If you don't, you don't. And somewhere maybe it's half in between. And sometimes it only works for large firms. Okay, so here we go. Now, here's if you want to be clever. This is a little bit too clever by a half, but I like this one. This one actually I came up with myself, but I'm sure you find it somewhere in the literature, so don't worry about that. But it's really quite clever from the point of view that you can actually ask people, why don't you do it this way? I say, nobody else does it this way. Okay, so the question is, does the EMVI really help to explain the dependent variable beyond the fixed effect and CVs? So you may have sort of a basic model. This is what sort of we agree on. It's a reasonable model of what explains the dependent variable. So you put in size and ROA and loss, no loss, and growth and ROA, a little bit like that. And then the fixed effects here. Why did you put in the fixed effects? Well, people like that. So I put in your fixed effects. Then you regress the dependent variable of fixed effect in CV. Now you get into what's being clever. Can I improve on this? Well, just extract the residuals from step 1. And then for each and every year, correlate the residuals with your MVI. So that's step 3. Am I clear? You don't need a doctorate degree. Then you check up what happens to this correlation. This can be done more in a more in a broader sense. In other words, it may be that the MVI or two variables and whatever have you. There are many versions of this, but this is what I have in mind here. If I have a basic model of the dependent variable, whatever it might be, then I can ask the question, two questions. One, what is the usual thing you would use to explain this dependent variable? And this is, oh, I think something is missing here. Well, identify what you think is missing, and then check up if that one correlates with the residual. It's beautiful. It's simple. And then you can just count the number of correlations of the right side. No, it's not perfect, but you're learning something. And it could, of course, be that the MVI correlates with some of the CVs, and that makes a difference, and that's a little bit missing now. There are many versions of this, but you notice the basic idea. So this is what you can do. If you do this and it shows up in your paper, you're on your own, because people do not like to see new things, because that brings up the problem that other people have to do the same thing, and then things fall apart. So when you do this stuff here, what you want to keep in mind, I just want to learn how the world works. So maybe when you get down to the step 4, maybe it's just 85%. Well, that's what it is. All right. Am I clear? Any questions? So there are many versions of this here. And then I get down to, this is sort of ridiculous. My final point, how am I doing time-wise? I'm doing okay, I think. Okay, yeah. All right, yeah, I'm okay. No questions, but I hope to hear from you. So this is, man, this is so boring. Use a holdout sample, if you can. People have 50,000, 60,000, 70,000 observations. They have 20 years of data and whatever have you. Why don't you use a holdout sample? Maybe 3 years, 4 years, or whatever have you. And it turns out that they actually do this when it comes to testing of trading rules. But you could do that always that way. Do you get the same thing? And I tried this. Sometimes people present papers, and I come up afterwards and I patronize and says, maybe you want to try a holdout sample here. I'm not sure it's going to work and so forth. And then the person looks at you and says, nobody else has to do that. And the holdout samples are truly scary. Because if you use OLS is sort of intrinsically fragile. It runs all over the place, which is a virtue, because if you try enough, you get 3 stars for the correct sign. But holdout sample becomes a tricky matter. You see, that's why when you have trading rules, we don't use OLS to validate it. And so people just do not want to do this step 1 and step 2 and step 3. And I think you can do it. And in some sense, it's sort of implicit if you do Farmer, Macbeth, and so forth. In other words, it's basically, don't stick out your head and do fragile econometrics like OLS. Because if you have holdout sample, it probably is not going to work out. But in general, if you do something which is the slightest fragile, use a holdout sample. But there are basic things you can do. You don't really need a holdout sample. If I do a correlation coefficient for 20 years, and I just want to correlate MVI and dependent variable, and I correlate the MVI and DV, I do that for 20 years, and this is what I find. I don't need a goddamn holdout sample. It is a holdout sample. In other words, it's sampling. All I'm saying is that open up, if you want to be clever and use econometrics, fancy stuff, use a holdout sample. So if you do something like a Mishkin's test, well, you can always fool around with the Mishkin test. You reject the null. But if you do a Mishkin test on a holdout sample, it would be scary. It would be scary. And you see, what it really comes down to is that, and I'd like to emphasize this, is that according to GARP, you can delete things and not to report on things that you don't like to see. Because on reflection, we shouldn't run this regression. It's fair enough. But the key thing is, if you play around, you got to have a holdout sample. So that's what it comes down to. It is perfectly fine to play around. It's perfectly fine to play around to get what you want. But if you do that, do yourself a favor. Check what happens when you have a holdout sample with the best possible model. So this is what we do in engineering. You do data analysis and they go through endlessly and try to figure out how the engineering works. And then they run an experiment. And the same thing is actually true in weather forecasting. They go through endlessly. How do I forecast the probability of rain? Well, try this, we try that, and we go through endlessly. Then it comes down to, we could have a holdout sample, sir, miss. So that's it. And the reason you do this is very straightforward. It's just you're trying to educate yourself, and you don't have any fake hopes or wishful thinking. You just want to know how it works, the world. That's it. Am I clear? Am I clear? So that's it here. And it's really in some sense pathetic in my mind, because people do these things and then they don't report on it. And that means I open up papers and they come up with these far-fetched hypotheses that the cost of capital is affected by tax returns and stuff like that. It's far-fetched. I don't read it. You don't either. There are good reasons. And if this is what we want to go on, it will go on. It's going to get worse and worse. And earlier I was talking with Mohamed about this, is that over the years, as the veracity of published paper becomes worse and worse, it becomes a self-fulfilling promise that gets worse. It makes it less and less likely that people read your paper. And the less likely it is that people read your paper, the greater are the incentives. I can just fake it. Okay. So that's sort of really what happens. I mean, people get busted now and then. All I'm saying is that first order of business, leave the idea of how to publish aside and start out doing things that tells you how the word works. And then you get down to the basic summary here is that, here's just some summary I get to that. Never ever forget, listen to this, my friends, that in the real world, if you have a reasonably interesting question, it will be somewhat messy. And don't expect that there are not reasonable ways of looking at the data. You may find there's nothing there. And then there are other ways of looking at the data. There seems to be something there. That's what you want to learn. That's what you want to learn. And you don't see papers written like that. In other words, it would be interesting to, this is what I suggest. It would be interesting if you write the paper and then you get down 3/4 in the abstract and you say, however, one can try a few robustness tests and then the conclusions are quite different. Then you share something with the readers. And that's it. Okay, so it's a mess here. So here is sort of a summary, 1, 2, 3, 4. Simplicity is a virtue of incredible things. And then use standardized regression unless you have a good reason for not to. And then use the modified Fama Macbeth, and then you use a holdout sample if it's called for. So these are my 4 suggestions. And if you happen to have econometrics textbooks, remove them from the bookshelf and put them in a drawer. That is not going to help you. The worst ones are really the serial correlation stuff. The horrible ARIMA stuff. Anyhow, so that's sort of what I have. And I feel quite happy about this myself. And this is what I do. I just finished a paper. I'm going to send it to John Hand. It's really, it's really about the forward EPs. No, analyst forecast, earnings and revenues. How does that connect with the current stock price? So the point being is, no, I'm not running regressions. And what I'm trying to do is just describe there's some natural questions, and this is what you're finding. This is what you're finding. So you may find, for example, that the forward EP is much better explained by growth in revenues than the growth in earnings. Did you know that? Well, maybe you did. So what is the difference? I tell you. But I don't play in games and says, oh, I get 3 stars. I don't have fixed effect and blah, blah, blah. So what I'm saying is that I actually follow this myself, but it's taken a long time for me to learn. There's a very natural thing to do. And this is when I'm going to keep quiet. There's a very natural thing to do as a young researcher. We tend to think research is a complex matter. Researchers are only for people who are smart and clever. So then you ask yourself, maybe I should be smarter then and do something more sophisticated than what you see is published. It's a very natural thing. And I got hit by that as a young man. Okay, so maybe you want to correct for clustering. There are many ways you can do it. I mean, you have to read the papers and you do it, and you have to look at the software and so forth. And what I'm saying is, if you want to do that and impress people, and we do that at Chicago and many other places, they impress you. And you sit like this. Wow, they're really clever. And what I'm saying is in my mind, if you want to learn about the real world, it's not what you need to do. If you want to do it for other reasons, all power to you, all power to you. But it's not going to help you to understand the real world. And there are many, many, many questions which are in the real world. So I would run into a question, for example, or in some sense, growth in revenue is more important than the profit margin. Well, if you listen to TV, they talk much more about revenues than profit margins. So I would say it's probably, in some sense, probably revenues and unexpected revenues are more important than profit margins and unexpected profit margins. The issue at hand is, if I want to tackle that question, do I need to go to chapter 13 in Green's textbook? The answer is, in my mind, no. Start out and ask yourself, if I can only use simple data analysis, what would I do? And I think I can guarantee you that if you do simple data analysis, you will start to see things and learn things that will stick in your head, what you want or know, and will be very useful if you happen to have a conversation with someone in the real world. Am I clear? Okay, so that's my message. Now I'm going to keep quiet here. Much talk.
Hi, Jim. Can I chip in a couple of thoughts, if I may? John
Yes,
Hamm
of
here.
course.
Yeah.
The first thing, I thank you, as always, for your talk. Really interesting and compelling. I echo many, many of the things you've said. Something I found helpful is just simply putting scatter plots in front of
Yes.
myself. Simple
Yes,
scatter
thank you.
plots.
Yeah.
That, I think, that visual is something that I recommend to younger researchers.
Thank you for mentioning. That's where things are turning now, and not scatter plots. You can just, in other words, you notice I did 2x2 table.
Yeah.
And what you're saying is that there's an expanded way of looking at that. You can actually do 3x3 with bars and colors and stuff like that. That's correct. The key thing is you're learning about the data. And the whole idea that you start out doing a dependent variable and MVI just a scatter plot. Of course, that's true. And then you start to, it looks like a scatter. Because the one thing people, scatter, the one thing people learn is that if you have a correlation of 0.1, it's actually a scatter plot. People don't know that. In other words, it's much easier to get 3 stars than a clear picture. Yeah, so thank you for that. Yeah, you're right. Scatter plots, whatever.
One other thing that I've been doing at least the last year, is following your suggestion of raising my hand and saying, can you tell me what the incremental adjusted R² of your main key independent variable is?
Oh, you do that.
This goes down like a lead balloon most of the time, but I think it's helpful to push, especially younger faculty, to think about this, because For example, I just saw a paper fairly close to home here presented where the number of observations was 13 million.
Oh,
And
yeah.
the
Oh, yeah.
t-stat was 2.1, and I asked what the incremental adjusted R-squared was. And you can sort of calculate it in a univariate sense. I think it was 3/100,000ths of 1%. So I wasn't trying to make fun of the person. I was just trying to highlight the fact that I think, as you've echoed here, incremental adjusted R-squared has got to be something that editors require be in the regular table format, because until that's required, nobody's going to be called to account, I think.
Yes, I mean, it's a very peculiar thing. That sort of, I'm glad you mentioned this here, because I used to do these things too. And the funny thing is that in general, if you look at the body language, people know that it's all bullshit. That's how I started out way back. And so they know what we're doing. But you're right. But on the other hand, I don't like requirements. What I'm saying is that it's just, if you as a researcher wants your paper to be read, it probably helps to be brutally honest, including when you write up the paper.
I agree, but I do
that,
think there's something on the editor's side that I think there's an abrogation of good technique if editors don't require certain things that are going to be uniformly informative to their readers. And I'll sort of leave it at that.
Yeah, I know. And it reminds me of a little bit in some psychology journals, we have new editors coming in, and then they have requirements that you have you have to go beyond stargazing and whatever have you. But yeah, one can try these things. I'm a sort of more believer in the open market that if you want to do that, I mean, what I tell young people is that if you don't put in the change in R-square, because most people know what the change in R-square is. They know. I guarantee you. And then you can tell them, they tell you that, oh, I have to check. Oh, I have to check. No, you don't. You already checked. Then I tell you is that make no mistakes. People may be quiet during your seminar and so forth, but they know. And they don't care. We all have to make a living. It's like all corruption. The thing is, if you start to require that you have to show your R change in R-square, then all sorts of people would come into, famous people would come into the light. You have, for example, Lloyd's and this thing, European, or, the famous paper with accounting principles, lower cost of capital. It doesn't have a prayer. The replication principle in practice is that you cannot replicate a lot of this stuff. So you come up. So the one way of looking at it is that this is what I try to encourage people to say to read paper. Don't take it too seriously, but you can think about the author as being a lawyer. And the lawyer says is that I'm going to make the case that this guy is not guilty. And I'm going to make the case that this is how this MVI explains the dependent variable. This is my case. It is not to say that it's true. So that's another way of thinking about how to read the papers. Are you with me in this regard? Yeah. So it's a tricky matter from that point of view. But obviously, the number of written papers about how classical econometrics doesn't hold up. It's endless. It's endless. They wrote that when I was young. In other words, for example, we calculate t-statistics. Well, if you have normally distributed, suppose the right-hand side is not normally distributed. Do you have t-statistics? No, you don't have t-statistics. Well, why don't we pretend we have t-statistics? Everybody does that. Everybody does that. And that's why I'm suggesting is that keep it simple and do robust, I don't call it statistics, do robust data analysis. And that sort of a peculiarity is that when you read papers, then you have descriptive statistics. That's where I pay my attention. But it's never, we just put it in. And then we get down to the main regressions and we talk about that 3 stars. And then we get down to it. Do I have my, oh, it's not my phone. So that's sort of the way it stands. It's very tricky from that point of view. But you see, the problem is you get down to my first slide. The problem is I have children, I have to feed my children. To feed my children, I really need to publish. And then you run into you have sort of a sense of what other people are doing. If I have to do the same thing, and I can feed my children, in other words, get publication, I will do so. That's my thesis. In other words, you really need to have, if you want research to be serious, certainly in the social sciences, you got to have independently wealthy people, do what they want. And then, of course, it still will be the case that a lot of papers are bullshit. But bullshit papers that are honestly produced is probably better than having fancy-looking papers that end up with known bullshit. In other words, there's nothing more annoying that people spend hundreds, if not thousands of dollars in submission fees. Then they spend thousands of dollars on editing. Is this what we want to do? And then we have 5 co-authors because you need 4 co-authors and 5 co-authors. So because you need risk sharing, you need the diversification there. I mean, it is unbelievable, our business, in my mind. But that does not mean that data analysis cannot be interesting. So think about it. You want to forecast the change in earnings? You want to analyze forecast errors? Interesting problems. Do it so you learn something.
A question
So, for example, if it comes to analyze forecast errors, maybe this really comes down to an outlier analysis. Interesting. Check.
Maureen, yeah.
So I'll just mention that the comment you had about less readership as sort of allowing potentially spurious or non-reliable correlations to just kind of persist in the literature is fascinating to me, thinking about where we've been as researchers. In other words, when we started, there were relatively few databases that everybody worked with. And so you had a sense of, you were correlating returns with all the earnings variables and thinking about what the data looked like. And increasingly, as you pointed out, there are more and more independent variables, 20 independent variables, increasingly coming from a much wider variety of data.
Yes, correct. Of course, you're right.
And so I think all of these things really contribute to the problem potentially becoming even greater as we go forward. And so sort of the timeliness of your prescription, I think is, very significant, because the more people do really carry out, underlying methods to, assess the robustness of the relationships they're studying. And the more that there's sort of a commonality of looking at that kind of analysis, I think it provides a check on, on results that won't sort of sit out there in the ecosystem as really fragile results that people get asked to incorporate and, continue to interpret weak results relating to them. So in any case, this general notion of how well can we really assess in the literature results that will or won't hold up. I mean, I think sort of looking at the paper and ex ante, seeing if they've actually carried out these kinds of tests could be a really important way to establish that. I'll also say, I always like to see a table 1 where people show where the sample came from, and you can kind of trace the numbers through and, understand, how the data drop off. But bigger picture, it's sort of the visibility that comes from sort of simpler methods versus more complex methods where you really, once you've got 20 variables in a regression, yeah, you've got no idea what sign you predict or what magnitude.
Yeah, but I mean, it really comes down to is that we have, I mean, there are many things that you raise in some sense, but it ultimately comes down to what is the demand for our research. Now, one thing is that there could be demand for our research, assuming it's honest. There is heavy demand for FSA research and equity analysis research. No question. No question about that. But then the issue is that if there's such good demand outside academia, then why should they have to publish? You should just record it in some sense. And then you have to rely on your reputation. Now things have become worse because people come in, ESG reporting is going to affect cost of capital. Yeah, go ahead. Nobody cares. Nobody cares. And the thing is that, so why does it get done? Because people want to build CVs. And the peculiar thing, then we get the secondary effect is that you want citations to. How do you get citations? You have to make friends. You have to make friends. And that's what people do. I make friends. I go to the conferences and I make friends. And you cite my paper and I cite your papers. And then some people recognize, well, I got to hang around at A+ institutions. Oh, because if you work at an A+ institutions, then if your papers does not get cited, you hurt feelings. Do not hurt feelings in our business, I tell you. You can stomp on people at third-rate institutions where people are over the hill. All power to you. But you don't screw around with people with positions. That's how people perceive it. So that leads to a very poor ethics in my mind. And what I'm saying is that, okay, it is what it is. But I think it's a huge mistake to say our research is intrinsic bias. I don't think that's true at all. I think that there are many subtopics which are really quite interesting, but the key thing is that you want researchers to be properly motivated. And my talk today is that these are the things you can do if you really care. Then you have the next step, your career. That's up to you. I have no advice.
Are there another questions? If you don't have any questions, you can open your mic and ask your question.
Yeah.
Professor Kenneth, you have any questions?
Oh, you? I'm sorry, I couldn't quite hear you. Oh, you were talking to the seminar participants.
If anyone have any questions, you can open your mic and ask your questions.
Yeah. Yeah.
Jacob can.
Am I missing something?
Could I chip in one last thought, if I may, and then unfortunately I need to head off the Zoom. I would like to see more no result papers. I think there's a terrible absence, in my view, of no result papers. Right. There are lots of no results that are interesting and should be published. And there's this weird asymmetry in the literature that you can't get a paper published unless the T is above 2.0.
This has long been pointed out. Yeah. And I think we have had journals that publish no results. In my mind, if you have an interesting real-world question, that's it. Your task is to say, if you look at the data this way, you find something. If you look at the data this way, you don't find anything. That's it, of course. But that's why people, you see, it's very peculiar, how this works, because if you have very simple questions, people stay away from them, because then the reviewers have opinions. So suppose I want to research risk and leverage. Man, why don't you do this? Why don't you do that? And whatever. You have to wear people out. And one way of wearing reviewers out is by having boring questions. And you do GARP. This is how we do business. I follow all the steps in our business, and this is what I'm finding. I have my 3-star robustness to workloads. Of course, I have economic significance and so forth. Please publish. It's well written. I spent $3,000 on editing. So that's our business. But I agree with you, for example, especially if you replicate things that there are claims and are sort of interesting. So there's endless things, for example, when it comes to forecasting analysts, forecast errors. There's certain ways of doing it. I think it works, but there are other ways of doing it. It's not going to work. In other words, my contention is that forecasting analysts, forecast errors, if you have a prior screen, so you end up dealing with outliers, yes, I think there are things, but on the prior interior screening, you have nothing. I may be wrong. But that's the point, is that there are many interesting things. That goes beyond trading rules. There are many interesting things. So, for example, if you want to value growth stocks, it's extremely hard. Okay, I keep quiet.
Are there other questions? If anyone have any questions, you can open your mic and ask your question. Ken, you have questions? You can open your mic and ask your question.
Good evening, sir.
Oh, good evening.
Oh, I'm sorry.
Yes, Ken?
Can you hear me?
Yes.
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 Well, Jim, thank you for the wonderful presentation. So my only question is, like, I'm interested in the the Ohlson 1995 very relevance kind of model, and I'm just curious, using your the theory that you describe in the paper, do you have any like specific or preferable requirements or updates on implementing that specific model?
Oh, no, I have not written on that. What I have to do is to, can you send me you have my email address? Ken?
Yeah. Yes.
Send me your address and I will send you something. Send me an
Okay.
email and I will deal with it, because it's a very good issue. The first thing is that we have to teach people about operating and financial activities. The only
Right.
thing I can tell you is the wrong way of going is the textbook. In other words, Riv on operating activities and then financial activities. So it's a very tricky matter what you do. But the valuation is a very tricky matter. The thing that's striking is that in the real world, what they do not do in the real world when it comes to equity analysis is to value the operating activities and then make an adjustment for financial assets, financial liabilities. This is not in the real world. So the modeling there doesn't, but there's some kinds of modeling there that's worthwhile. So send me your email and I will send you something you can look at. It's a very tricky matter from my point of view. It's a tricky matter because things I've said way back, I think, are at best not helpful, at worst outright misleading. So many my sort of well-known paper is actually correct conceptually and whatever, but I've written other papers which I'm not exposed unhappy with, because it doesn't connect sufficiently with the real world, and there's good reason for that. And it has to do with the fact that part of the literature is very contaminated by the fact that when you apply things in the real world, they do not like to use discount factors, and there are very good reasons for that. So the whole idea of going from, the textbook thing of going from expected return on equity to WACC, it's not done in the real world for very good reasons.
Thank you. I'll send an email to you.
Yeah, send me an email to you.
Yes, last
be happy.
question from Ken.
Yes,
Ken,
I'm good. Thank you.
Yeah. Ken, you can ask.
Good evening, sir. Thank you. At least good evening from Kuwait, by the way. My question is related with the winsorization of the variables.
Huh?
Winsorization of the variables. People are winsorizing the variables, so there are...
Winsorizing, yeah.
Yes.
Oh, man, yeah.
So what is your point on this? And for example, I am using
It's
a
just
1.9.
plain stupidity, which is used to be able to reject the null. The problem we face is that you do not have to use OLS. And when I add on OLS has no merits, unless you're willing, you view it as a merit, you can fish around and get what you want. The econometrics literature is loaded with stuff where you do not have to windsorize, and it doesn't cause problems. The problem is that once you do serious econometrics, you get serious issues about t-statistics. So it doesn't work. In my own case, I use so-called Tilesen, TS. Have you heard about TS?
No, sir.
Yeah. So anyhow, that's what I use. TS is super simple. And you can think about if you use TS and add noise, then you get OLS. Pure noise. In other words, OLS has no known virtues. What else can I
Okay.
tell you? That's not Jim Ohlson in action. So such paper, the statistics literature is full of stuff telling you how to estimate things. You know, it's just full of it. You can just use common sense to. There are alternatives to OLS. But the thing is, it scares the heck out of people not to use OLS. OLS has only one, quote, virtue. It allows you to reject the null with some ease when the null is in fact true. Am I clear?
Yes, sir.
Yes.
And
That's
my
the
second,
thing.
Oh,
my
I don't
second,
use-
I
Moraine?
was just going to mention, I put an article in the chat, your paper with Sewa Kim from
Yeah.
2015 on Tilesen.
Yeah. In other words, you can just check. Look, my friends, if you really care about it, you can run your own simulations. Try different estimation techniques and check out what works the best. And all I'm saying is that, I mean, I can repeat. The reason OLS came around was that for the longest time, it was the only thing computers could handle. Once you got really sophisticated chips and so forth, you don't need to do OLS. But why people stick to OLS, we learned about OLS, and it looks beautiful, you know, x prime minus 1, x prime y. You can show it to your significant other, and your significant other thinks that you're a real academic and so forth. It has no known merits. Yeah, so I have a paper with which I just tried out, which is sort of kind of trite, with Kim, Ohlson Kim. I think it's in some journal. And yes, TS works better than OLS if you care about realities. We knew that because OLS works very poorly. So that's why they have this winsorization. It gives you 1 more degrees of freedom. You can screw around with it. Of course you can get what you want. The problem is that many papers and stories should focus on the outliers. If I study, for example, the classical cases, sports performance in professional sports and how much they pay, focus on the outliers, especially the high one. And like now I'm working on the forward EPs. And it turns out that forward EPs or PEs are really nasty when it comes to growth stocks. If you look at the outliers, you know, you may have heard about that. The Magnificent Seven, you know, these are the US growth stocks. What I'm saying is that they are very hard to explain what their forward PEs. So the focus should be on forward PEs. So that means that you don't want to delete the outliers. It's just common sense. So what I'm saying is start out doing your analysis using very basic data analysis. And OLS, in my mind, is not helpful. Sometimes it's very helpful because people understand it. So you can sort of do it as subordinated stuff. I run a regression here and there. That's fine. but don't take it seriously. And above all, don't get involved with this stargazing too much. Don't view stargazing as being centrality and to arrive at a conclusion. It's just silly. Shall I repeat that?
No, sir.
Don't get involved in stargazing as to get the key conclusions.
I understand your point. May I ask a secondary question?
Please.
There are many models that measures the financial constraints. There is yours, there is Altman Z-score, and there is Kaplan-Zingales. But all these models are developed in the United States, and interestingly, some people are using it in different countries with their measuring coefficients. What is your point on this, and what do you think of this? Because
it's a different, broadly speaking, there's another question. What is the role of theory when you do data analysis? And when you see these papers where it sort of looks like you're doing engineering, and if you start to take your coefficients serious, then it's all bullshit. There's a peculiar thing here. And let me try to say this because it's close to my heart. As a doctoral students, we often learn, I certainly did, that first you do the theory, and the theory shows up in an appendix, and then you do empirics. And in some sense, when you do the empirics, you should connect with the theory. In my mind, that is absolute bullshit. It's a very peculiar thing. There is good theory because it allows you to organize your thinking, but never ever take it literally, not even with Black-Scholes. So you see these when you see these empirical papers with appendices, I say, forget about it. So here's the task you have to convince yourself. You got to have role models. Read papers and pick a paper where you have an appendix which is supposed to be of some importance. Ask yourself, did you find this worthwhile and interesting? The answer is, in my mind, I'm lazy and work averse. It does not work. It does not work. It's a very peculiar thing. So you can do theory, for example, about, say, risk aversion and the expected return on market portfolio exceed the risk-free rate. These are insights. But then people write these down, these models, and they have parameters. And then the parameters are supposed to exist in the real world, but they don't, because everything hinges upon how you do things. And it's a very, very tricky and almost a little bit tragic, but that's sort of how things are in the social sciences. So the idea is that the social sciences are supposed to resemble the real sciences, and it doesn't work. It does not work, in my mind. So it's a little bit like I'm trying to find some good parallel. People write down, they have these equations and then they assume normality and they come up with all of these coefficients and so forth. And then they start to take these coefficients seriously. You can't. You cannot. And it's just how it is. And so there's sort of a similar thing here. And then we got to get going here. But here's sort of another observation. So you got to listen carefully. When you learn econometrics and regression theory, right? The impression that's conveyed is that there's a true model. That's the regression model. Then you bring the empiricist in, and he or she then are supposed to give you the numbers. And there's a very peculiarity there because what we do is to deal with MVIs and controlling variables. They don't do that really in econometrics textbooks because the spirit is so different. The spirit of econometrics textbooks are fundamentally wrong. That's my conclusion. I'm not alone, of course. So that's sort of a little bit like you learn about estimated standard errors, right? You learn about that in econometrics. And, it's going to show up on exams and so forth. Now you tell me, when did you, sir, miss, read a paper where they actually had a discussion about estimated standard errors? Did you ever see it? Did you ever see it? The answer is no. I read journals. No. Instead, what people do is they pay attention to the change in R square, and that one is not reported. That's where we have a problem. And that's one reason I prepared this simplistic talk, is because what I'm saying is, suppose you didn't know any econometrics, what would you do? Well, maybe I should look at the plot. Maybe I should do a 2x2 table. You remember Ball Brown? Do they have a 2x2 table? Did you read Ball and Brown? No? Okay, no, they have. The point I'm making is super simple. If you see a 2x2 table and you have a reasonably interesting question, you remember it even if you don't want to. When you correct for clustering, you remember what people do? No, you don't. You don't quite know what you're doing. Do you feel like that you're going to look up on the internet what the correcting for clustering is all about? No, there are 4 methods. Are you going to learn that? No, you're not. So why do you do what you have to do? Because I'm told to. And presumably GARP helps me to arrive at valid conclusions, which are the ones I want. That's my speech. And it's not going to change. Yeah, it's not going. In other words, what my final words is that if you don't agree with me, it is perfectly fine. But convince yourself and do not engage in wishful thinking.
Are there another questions? If anyone have any questions, you can open your mic.
Yeah, more questions. Yeah.
Yeah, Peter Aston, you have any questions? If anyone have any questions, you can. Yeah, Peter.
I don't have a question, but I have a comment.
Yeah.
Jim.
Oh, hi.
Yeah. So,
Did you just sign up?
no, I've been here a while.
Oh, okay.
You know, respectfully, I've got to tell you that I saw most of this 40 years ago.
Huh? Yeah.
Yeah, I mean, this is what you taught us as PhD students 40 years ago.
Not quite, no, but sort of, yeah.
Yeah, it was 40 years ago.
No, I'm talking about content, not the years. Okay.
But the basic ideas of knowing your data, you know, the holdout sample, all of that stuff, it's been around for a long, long time.
Oh, man, of course you're right. Yeah.
Yeah, I mean, my only observation is that I don't know how you penetrate the alternative audience, but this doesn't seem to be the audience for this paper. It's the editors that should be reading this paper. And more.
No, I think I know what you're saying, but I think I disagree with you because somewhere along the line, I think the issue is that when people do GARP, people engage in what I view, certainly in my case, is an element of wishful thinking. It's sort of sensible. What I'm trying to do is that it's probably not really sensible. It's an overstatement of it. And really, if you have to do research that's believable, you got to start over. That, in my mind, is somewhat new in my mind. In other words, there's a way of going that GARP, intercepted research procedure, it's not that bad, really. It's just a little bit that people could be a little bit more honest and they could do a few things more and so forth. Yeah, there's some truth to that too, but it really comes down to that. In my mind, editors are not going to change it. It's sort of, you know, corrupt systems are corrupt systems, they collapse. And so that's my feeling. And what I hope to do is really, I feel not repeating myself, and certainly you heard of this before, is that you really have to think through, what is it that I should be doing if I want to learn about the real world? And then I would say that over years, I shifted around much in terms of what should be done. And then I'm trying to, I've been disciplined by the fact that it's sort of peculiar. It's just common sense and simplicity that should drive everything. And that is not really how people, that's sort of difficult for people to do. In other words, the editors are very sophisticated. They strongly and honestly believe, in general, I believe that we believe, that good research is somewhat sophisticated. Papers should be well written. They have to correct for clustering. People should be well aware of all of these fixed effects and so forth. And I think that's what we believe. And what this is sort of is it's just a suggestion. This is sort of simplistic stuff. And the only thing I can offer, this is sort of what I want to do if I want to learn about the real world. But there is a difference in terms of learning about the real world to publishing.
Exactly.
Do I answer your question? In other words, I mean,
Well, you sort of did, but
you have a very important point from the point of view, which is in my mind is of course straightforward. In some ways, there's nothing new. There are famous economists and statisticians. I've read papers about it. I never tabulated it, but there are papers by famous economists that state that what you see in American Economic Review cannot be taken seriously. And my mind is maybe a little bit different from a point of view. I actually think accounting research can be taken seriously. I think there are many interesting topics. I actually think that. And from that point of view, so I don't think that at all that our sort of accounting, what's accounting anyhow, it shouldn't be part of the social sciences. Well, maybe it shouldn't be part of academia, but I strongly believe that data analysis of accounting data in financial market can be highly productive, very useful, and there's real demand for it. That's what I believe. But I don't believe particularly that the ESG is going to be important to explain the cost of capital.
I agree.
And that's sort of the bullshit that's coming now, and that was sort of raised earlier. But I'm a capital market guy, but that's my prejudice and that's my background. It's the capital markets. But I strongly believe that there's intrinsic research that can be done about capital markets, which is simple and straightforward and worthwhile. In other words, if I was running a hedge fund or some fund like that, I'm not, of course, so I could well see that you would have people who do research. So I don't know if you agree with that or not.
No, I definitely agree with you.
Yeah, in other words, that's sort of like the background, and much of it's sort of, oh yeah, I love it. We can go on endlessly, but there are these famous scandals now with this Harvard faculty member, in the behavioral science, you know what I'm talking about? What's the name? Italian? Yeah. So we have all of these scandals going on in behavioral economics. And it's sort of farcical because when you read the papers, they actually manipulated the data unethically. But when you read the papers, you can say, who the hell would ever take this seriously? It's almost amusing. So then, so you have these rather idiotic things, and then they start to do behavioral data. But it turns out that if the people who do this stuff, it turns out they're superb personalities and give extraordinary expositions, and they're very good writers. So it's sort of a peculiar business. Hey, if you know how to present properly and you're a good writer, you can come up with all sorts of bullshit. You shouldn't have to come up with fake data. Just do it. It's sort of a little bit like what we have. The Lutz paper, for example, of you introduce new accounting principles in Europe, and then the cost of capital goes down. Yeah. Go ahead. Go ahead. Maybe it's true. So that's sort of my point of view. In other words, I actually have a paper now, which is my only paper, where how should you do research? In other words, I think in my own case, if I can talk about my own case, it's kind of boring. But over the years, there's something about that you like to stick that what's going on in our business, the great bulk of it is worthwhile. And as I looked at it closer and closer, I find more and more critique. And that's how I moved on to this, that people told me, so what should we be doing? Well, it's all straightforward. So that's it. One doesn't have to, it's sort of an anti-econometrics thing. I don't know. You can call it anti-econometrics. There's nothing I'm saying here which is not totally elementary.
So I might not call it anti-econometrics as much as pro-transparency on understanding the underlying relationships in the data. I mean, I agree there's there's an anti-econometric theme there, but you know, the reference to the Harvard study, that was certainly one I was thinking about in terms of just less visibility into sort of the underlying structure that's generating results. Certainly in a lab when people are collecting their own data, you know, anything.
Yeah, but you have to keep in mind that in my narrow mind, learn how to live with ambiguities in the real world. Learn how to live with ambiguities in the real world. So that means that abstracts should not be the way they are now. They always talk about, we found this, and then they declare victory and all robustness test, and it's sort of farcical almost. Have you checked up on this economic significance? Have you checked it? Do you find papers that says, oh, we checked up and we found in this and this, but when we look closer, there's no economic significance, we're sorry to say. In finance, in corporate finance, someone surveyed all of these papers for economic significance, and I think it came in that 98% of all papers declared economic significance. 2% said that they could reject it. Ha! What are we supposed to do? I laugh. What do you do? What do you do? I laugh. Maybe I shouldn't be. Maybe it's a sign of naivete and laziness or whatever have you. But somewhere along the line, you have to confront that. And that's when it comes down to this economic significance. I am amused, sick and tired, both when people come in and present their paper and they talk about the robustness test. They always work out. Yeah, sure. Why do we have robustness tests since we know they're going to work out? Am I clear? So maybe I'm wrong, but that's what I'm saying is that feel free, of course, to disagree with me. But I get back to the first slide. Do not get involved in wishful thinking. And I think that when I look back upon my past, I think I have been involved in wishful thinking. So that's it. What do you say, Peter? Are you there, Peter?
Your
You're
mic
on
is
mute.
mute. Mute.
Sorry about that. No, I can't agree with you more. I'm just questioning the audience. I'm sort of back to my
Oh, I
point.
see, yeah.
You know, I think it's great that this is all put in one document in a very simple fashion. At the same time, there's sort of this difficulty that many of the people in this audience face that you're aware of.
Yes,
You know,
I am.
for example, I pushed a group of researchers on having a holdout sample. And eventually they decided not to have the holdout sample because they concluded that the referee wouldn't believe them, that they had actually done it.
Yeah, you know, that it goes
That's
on endlessly.
It's not at all surprising.
No, nothing is surprising once you get down to review process and people's extreme feelings about the review process and probabilities.
Yeah.
You can go on endlessly with it. I agree. All I'm saying is that think about it this way, Peter, is that, or any one of you who's listening today, if it weren't for reviewers and the need to publish, what would I do? That's really the question.
Jim, I have a question for you here.
Oh, hey.
Hey, Jim. Of course, I really appreciate this type of talk and discussion. It really goes to the core of some very fundamental problems that we have in current research. So my question to you is, do you think that there will be any kind of correction of this? Because, I mean,
Oh, yes, my answer is yes.
It's very
In
hard.
other words, there are many examples in the
what is going to be the tipping point?
Oh, the tipping point is really that it's lurking in the background. It's actually part of Trump is that, but this has been floating around quite a bit. And I read up on it in terms of history, is that that research collectively for subfields produce nothing. And then ultimately the demand in the classroom also goes down, or it goes outside academia, and then it disappears. So for example, there are many, many examples. And if you look, for example, in philosophy, fancy philosophy, during the 1930s, that was big in continental Europe and Oxford services. You know, all of this, you know, you were philosophy professor. You could walk around and you were well paid and everybody respected you. Classrooms were full. Then after the war, they decided this is a waste of time, basically. Students disappeared pretty much. They still have trickles of it, but it sort of disappeared. And you can go back to the, if you go back to the Middle Ages, you know, in Paris in the 1400s, you know, they had lots of research at University of Paris. But then somewhere along the line, in the early Renaissance, they realized it was all bullshit. They realized that in Italy. And it got cut out. You know, in other words, the idea of trying to mix the Bible with Aristotle, you know, it doesn't work. So they have a history of things which doesn't work. Now, this is very, very big now in nutrition, you know, and in other words, in drug research and related to drug research, you know, all of these papers are statistical and so forth. And that's why you need this paper and so forth. It's big. People are sort of very suspicious nowadays. And there are many, many, many articles on the internet that collectively not much is accomplished. There was a very big article in the New York Times, I think yesterday, before yesterday, about the research in Alzheimer's. It's been singularly unsuccessful, the claim was in the article. And moreover, the lack of success was due to strange incentives. Papers were not valid. So what I'm saying is I think the same thing here. When it comes to the education of CPA and professional accountants and so forth, it doesn't really need to belong in the universities, so we can cut it out. That does not, in my mind, mean that research in accounting and financial statement analysis and bankruptcy forecasting and equity valuation, it will be important. But if we can get rid of a yoke of building CVs, we'll be way ahead. So that's sort of my answer a little bit to your question. I think it will collapse. This easily can take 10, 20 years. But ultimately, I think that's what's going to happen in the social sciences in general. They actually had a senator from Texas, a Democrat, 15 years ago, 20 years ago, or something like that. She wanted to pretty much close down research in the social sciences at University of Texas. People are aware of that there are problems with research. And part of the problem is as you would predict, if the cost of word processing goes down, you would expect to get an enormous amount of bullshit. And that's what we end up with. And then we create an artificial market, which is CV buildings. But I mean, we talked about this. And I think that if you look at, I don't know about you, and I don't know about Peter, what impressions you have, but because there's self-selection. But I think that many, many, many senior faculty have been around a lot. They don't think that we're really adding value. So do you think we're adding value? If you open up the JEU, do you expect that you find interesting articles? No, you don't.
Well, what I see is, of course, that many articles address very kind of esoteric
of course we do.
Problems that address questions that really nobody asks, and that are very far away from the classroom discussions that we have.
Yeah, but then it sort of feeds upon itself. If it's a boring question, nobody's going to read it. If nobody's going to read, you might as well invent the numbers. But be careful. Yeah, that's how it is in my mind. But again, I mean, this happens in all sorts of human activities. You know, people write papers and papers and papers and papers, and they arrive at conclusions and whatever have you. But the problems abound. That's what I would emphasize. The problems abound. It's not accounting. It's very abundant, you know. I mean, I think in social sciences, we publish 1,000 papers a day. 1,000 papers get published per day. That's what I heard. I don't know. It's probably true, right? So maybe now and then you're part of a pile. It's like this. But you can see here is that a paper like this, it really cannot be published. And I don't feel bad about that. I don't feel sorry for myself. The question is, do people learn something from things? But people, I think the young people get really, really, really frustrated. But you're not supposed to talk about it. And, you know, you have in the seminars, you know, it's like John Hans said earlier, you know, you can ask the question, what happens to the R-square if you delete the DVI? No, MDI. Oh, people say, oh, I have to check. No, they already know. So why do we play these games? Why do we play these games? What's your answer? What is your answer? So then people say, well, it's you over the hill, so it's easy to talk. Yeah, I agree.
Thank you very much, dear Professor James Ohlson, for your contribution and your effort. It's really an
Yeah,
excellent
it comes
presentation.
as the saying goes, it comes for free, and that's exactly what it's worth.
Yeah, thank you very much. Thank you very much, everyone joined us today. And thank you very much, dear Professor James Ohlson, for taking the time to present to us today. It's really appreciated.
My
Thank
pleasure.
you very much.
Yeah, I like to talk. Yeah.
Yeah,
All
and
right.
I hope,
Thanks everybody for the question, and thanks for
Thanks,
listening.
Jim. Great to see you.
Very nice. Thank you.
yeah,
I'm
and
glad.
I hope to see you soon in Egypt. You are very, very welcome.
Oh, okay. Thank you. All right, folks.
Yeah.
I'm